Hi, my name is Didarsh, and today I will show you my Rube Goldberg machine in action and explain the physics behind it. Let's start by looking at an overview of this machine. This Rube Goldberg machine can be divided into 8 segments which allow the task of turning off the lights to be performed. Before I show you my machine in action, let's look at the physics behind the entire machine. Segment 1 is the first ramp of the machine. The ball is placed onto the ramp with no external force applied onto it. At the moment of release, the ball has only gravitational potential energy. This is because the initial velocity is 0, making the kinetic energy 0. As the ball makes its way down the ramp, energy transformations take place, causing the ball to gain and have an increase in kinetic energy as the gravitational potential energy decreases. This is due to the ball getting closer to a height of 0. Here, the law of conservation of energy is clearly seen. As the ball makes its way down the ramp, no energy is lost or created. It only changes form from one to another, which in this case is gravitational potential to kinetic. To add on, as the ball travels down the ramp, the only two forces acting on it are the normal force and the force of gravity, assuming there is no friction. As the ball reaches the bottom of the ramp, it has only kinetic energy and no gravitational potential energy. During this moment, the ball collides with a paper roll in a somewhat elastic collision, transferring its momentum and kinetic energy to the paper roll, starting the second segment of the machine. This contact force applied on the paper roll from the ball causes the bottle, which is resting on top of the paper roll, to fall. When the bottle is at rest on top of the paper roll, it only has gravitational potential energy and no kinetic energy. But as it begins to move, energy transformations occur and it gains kinetic energy. The bottle makes its way to a cylindrical object sitting on top of a ramp, during which the only two forces acting on the bottle are the force of tension from a string attached to the roof and the force of gravity. The bottle then collides with the cylinder in an elastic collision, transferring both momentum and kinetic energy to the cylinder, resulting in a force being applied to the cylinder, beginning the third segment. This contact force from the bottle pushes the cylinder down a ramp, during which, similar to the first ramp, energy transformations between gravitational and kinetic energy take place. After the cylinder makes its way down the ramp, an elastic collision with a book occurs, which results in the cylinder imparting a force onto the book, transferring its momentum and kinetic energy, beginning the fourth stage of the Rube Goldberg machine. During this stage, the force applied by the cylinder onto the book causes the book to fall over, which in turn acts as a domino and has an inelastic collision with another book, causing the second book to fall over as well. This second book imparts a force onto a resting ball, beginning the fifth segment of the machine. The ball makes its way down a ramp, during which energy transformations occur once again between gravitational potential energy and kinetic energy. After the ball makes its way down the ramp, it enters free fall, starting the sixth segment. During this free fall, the ball travels at an angle during which the only force acting on it is gravity, assuming there is no air resistance. Energy transformations also occur during the free fall. As gravitational potential energy decreases, kinetic energy increases. This causes the ball to accelerate towards a platform onto which it collides in an elastic collision, transferring momentum and kinetic energy onto the platform, beginning the seventh segment of the Rube Goldberg machine. The collision with the platform causes it to rise up from one side, allowing a spring-loaded car to begin moving. Inside the car, an energy transformation occurs. Elastic potential energy stored in the spring located inside the car is transformed into kinetic energy as the car begins to move. The spring-loaded car is attached to a string, which on the other side is attached to the remote control of an RC car. The forward motion of the spring-loaded car applies a force onto the remote control of the RC car, causing the RC car to begin moving, starting the final segment of the machine. By imparting a force onto the button of the remote control, a signal was sent to the RC car, causing it to move forward. The forward motion causes a force to be applied onto the light switch, which was attached to the RC car by a string, causing the lights to turn off, therefore completing the task. In total, during the 8 segments of my Rube Goldberg machine, around 6 energy transformations occur. To add on, this machine was also an open system, meaning that some energy was transformed into other forms, such as sound, and some thermal, caused by friction. Now that the physics has been looked at, let's look at the entire Rube Goldberg machine in action. 3, 2, 1. After analyzing and collecting measurements from the machine, the following data was collected. Thanks for watching.